So chapter 3, we are now going to learn about the differentiation rules. Now that we already know what the derivative of a function stands for, remember it's just the rate of change of the function, and we did it both at a value, at a, or in terms of a graph, if I started with a function and I sketched its derivative. Now we're going to look at different rules. So instead of doing it graphically and instead of doing it using the definition, the formulas, we're going to figure out different rules to find the derivative. Okay, so the first one is the derivative of a constant, which we talked about this in class. So the derivative of any constant is just what we know is just 0. First of all, this notation, d over dx like that, means the derivative of. Okay, dy dx means y prime, so that would be like dy dx equals 0, the derivative equals 0. If I have d over dx, that basically is saying to find the derivative of whatever's next. Okay, why is the derivative of any constant 0? Well, if you look at it as a function, any constant is just a horizontal line, and the slope of that line is 0 always. Okay, so there's our first rule. Power functions. Now we're going to come up with a rule for basically for polynomials, for any x to some power. Okay, and what I have here is use the definition, use the actual limit definition to find each. I'm just going to kind of skip that and say, all right, the answer to the derivative of x, if I actually did the limit, the definition out, the limit as h goes to 0, I would get 1 for that. Okay, the derivative of x squared, if I did that out, I would get 2x. Okay, and again, we talked about in class, if I start with linear, the derivative is a constant. If I start with quadratic, the derivative is linear. The derivative of x cubed comes out to be 3x squared. So again, I start with to the third power, I end to the second. So you might see the pattern that the derivative is always the exponent's 1 less. The derivative of x to the fourth is 4x cubed. Okay, so here's the rule. The rule is the derivative is always going to be you take the exponent and bring it down in front, and then you subtract 1 from the exponent. So if I just did x to the fifth, the derivative of x to the fifth would be 5. Bring the 5 down, x, and 5 minus 1 is 4. Okay, x to the sixth would be 6x to the fifth. That's my power rule. So here I have it defined. The derivative of x to the n is always n times x to the n minus 1. Isn't that nice and handy? So the derivative of x to the 8th would be 8x to the 7th. Okay, so that's the power rule. Pretty straightforward. Now you only can use this if I have x to some power, or I have a number in front, which we'll get to. Okay, so a couple more examples I have here. If I have 1 over x squared, you just have to rewrite it as x to what power? So 1 over x squared would be x to the negative 2 power, and then you can apply the rule. Bring the exponent down, subtract 1, negative 2 minus 1 would be negative 3, and I can write my answer as negative 2 over x cubed. Okay, the derivative of square root, well, write the square root of x as a power. The square root of x is the same thing as x to the 1/2, and now I can apply the rule. Bring the 1/2 down, subtract 1, 1/2 minus 1 would be negative 1/2, and then I'm just going to rewrite this as what? 1 over 2 root x, and I can rationalize that if I want to, root x over 2x. So the idea here is you first have to write the function as x to some power. Okay, next one, write this as x to some power. So this would be the same thing as x to the negative 4/3 power. Now once I've done that, take the exponent down, subtract 1, and I get negative 7/3. Rewrite it as a root function, which usually we do. Oops, sorry about that. So I would have 1 over 3, x to the 7/3 down here. If I wrote it as a root function, it would be 3 cubed root of x to the 7th. Okay, either one. This is would be okay because I have a positive exponent there. Just depends how you're asked to write your answer. Okay, so pretty straightforward, that rule. Makes things easy. Another idea here. So we know what a tangent line is. A tangent line, the slope of the tangent line is the derivative. Here's a new line we're going to talk about. The normal line to a curve is a line that's perpendicular to the tangent line. That's all. So if we talk about normal line, it's the line that's perpendicular to the tangent line at that same point. So you still would find the slope of the tangent line, and then you remember, hopefully, that perpendicular lines have opposite reciprocal slopes. Okay, so number 9, find the equation of the tangent line and normal line of. So my function is y equals x root x, and my point is 1, 1. So first thing I want to do is write x root x as a power. So this is the same thing as x times x to the 1/2, which is the same thing as what? X to the 3/2. If you add the exponents, 1 plus 1/2 is 3/2. Okay, so the derivative of that, which I'm going to use y prime notation, is bring the exponent down, 3/2, times x, 3/2 minus 1 would be 1/2. So there's the derivative, which I want to write it. If I want to write it as square root function again, I can write it as 3 root x over 2. Now, the equation of the tangent line at 1, 1, I would actually plug 1 into this to figure out what the slope is. Okay, so f prime of 1, if I plug 1 in, what do we get? We get 3/2. So the equation of the tangent line would be y minus 1 equals 3/2 times x minus 1. There's the tangent line. The normal line, which all that means, guys, is it's still at the same point, 1, 1, but the slope would be opposite reciprocal because it would be perpendicular. So it would still be y minus 1 equals negative 2/3 times x minus 1. So normal line is the slope is opposite reciprocal to the tangent line. Okay. And the last real rule here. What if instead of just being x to the 3rd, I have a 5 in front? Well, we're allowed to just leave that there. So the derivative of a constant times f of x is the same thing as c times the derivative of just f of x. So basically, you're going to do this by saying it's 5 times the answer to the derivative of x cubed. You just leave that 5 there. So I would do 5 times what? Bring the 3 down and subtract 1, and then you just multiply the 5 and the 3. So my answer is 15x squared. So when you bring the 3 down to do the derivative, you're multiplying. That's all. Really not that crazy. Okay, you're just going to bring that down to multiply. So if I had 7x to the 4th, the derivative of that, I bring the 4 down. 7 times 4, I would do 28, and then x to the 3rd, subtract 1. Okay? Next, sum and difference. So now what if instead of just having one term, I have a whole bunch of terms? And just like you'd think, you could just do the derivative of each one. So formally, the derivative of f of x plus g of x is the same thing as the derivative of f of x plus the derivative of g of x. Which just means you can do each term by itself. So for 11, I would just do each term. What's the derivative of 3x to the 5th? Bring the 5 down, so it would be 15x to the 4th, minus, next term would be 6x squared. Next term would be minus 2x. Now what's the derivative of a constant? 0. I don't have to write 0. There's your answer. How nice is that, instead of using the limit formula? Okay, now a little tricky. What if I don't start exactly with a polynomial? So what you have to do in order to use that rule is you have to create a polynomial that just has individual terms. So how would you do that? I would take this function, minus 6x squared over 8x, and the square root of x is the same thing as x to the 1/2. I would divide every term by x to the 1/2 so that I could use the rule. So I would do 5. What's x to the 3rd over x to the 1/2? What do you do to exponents? You subtract them. So it would be 3 minus 1/2, which is 2.5, which is what? 5/2. Sorry, x. I didn't mean to write that 5 there. So it would be x to the 5/2 would be my first term, minus 6 Next one would be 2 minus a half, so this would be to the 3/2. And last one would be what? 1 minus would be 1/2. Now I could do the rule. So now I would do each term. So for the first term, I bring the 5/2 down, so I'd have 5 times 5/2. So I'd have what? 25 over 2, okay, x, and then I would have 5/2 minus 1, which is 3/2. Okay, minus next term, bring the 3/2 down. 6 times 3/2 is what? 9 times x to the 1/2. And then, oh, I forgot the x here. Sorry, guys. Minus, bring the 1/2 down. 8 times a half is 4. X 1/2 minus 1 would be negative 1/2. So once you create, when I'm adding and subtracting terms, a polynomial, then I can do the derivative of each term using that rule, where you bring the exponent down, multiply them, and subtract 1. But you have to first divide by whatever's in the denominator down here. Some of you might be thinking, what if it's not just one term? So what if, here's your big, what if it is x squared minus 6x minus 3 over x minus 1? We cannot use this rule for that. The next section will address this. We'll do rules where I have a polynomial in the denominator. Right now, it's just going to be one term in the denominator, so you can divide everything by that term. Okay. Now we just have a couple random questions to go through. So find the points on the curve where the tangent line's horizontal. You're thinking in your head, what does that mean? Where would the tangent line be horizontal? What does that mean? That means basically, guys, where the derivative equals what? 0. So what do? You find the derivative, find y prime, which would be 4x cubed minus 12x, and set it equal to what? 0. And then solve. I could factor out a 4x, so I'd have x squared minus 3, so I would get 0 and plus or minus root 3. And now just be careful. It says find the points on the curve. So now I actually want to plug those back in to this to find the actual y values that go with each one. So if I plug 0 in, I get 4. If I plug root 3 in, I get negative 5. And if I plug negative root 3 in, I also get negative 5. So those are the points, the xy points, where the tangent line would be horizontal, which means that's where the graph does what, guys? Changes direction. That's where your local maximums and minimums would occur, because that's where the derivative is 0. So that's where the graph does this or this. Remember, that's when I have a horizontal tangent line. Next, I have an equation of particles. So I have a particle. There's the motion of the particle. That's its position in centimeters. Find the acceleration. So acceleration is which derivative? Let you think for a second. Acceleration, second derivative. Okay, so the first derivative is your velocity. So your velocity would be 6t squared minus 10t plus 3. There's my velocity, which is just the derivative of this. My acceleration is the derivative of velocity. So that would be what? 12t minus 10. So there's my acceleration. And what's the acceleration after 2 seconds? Now just plug 2 into that. So I would get what? 14. And now I haven't talked about units. So velocity's units would be centimeters per second. Okay. Your acceleration is going to be centimeters per second squared. Okay, because it's what? It's rate of change, centimeters per second really, if you think about it. So acceleration would really be the change in velocity in terms of time. So it would be centimeters per second, which is centimeters per second squared. Okay. So anytime now you're asked for velocity or acceleration, you're just finding the derivative, and we can use the power rule now instead of using the actual limit formula. All right, last thing, exponential function. So what's the derivative of e to the x? We've already talked about this in class. We know it's it's itself. The derivative of e to the x is e to the x, okay? At what point on the curve y equals e to the x is the tangent line parallel to that line? Okay, so tangent line parallel to that line. Parallel lines have the same slope. So that would mean the slope equals what? Equals 2. Okay, that's what that question's really asking. How do you find the slope of the tangent line? Well, it's the derivative. So what's the derivative of e to the x? It's e to the x. And we want to know, when does that equal 2? How do you solve? Go back from last year in even algebra 2, take the natural log of both sides. So if I take the natural log of this side, I just get x. So it would be the natural log of 2. So my answer to this question is natural log of 2. Again, if I want the point on the curve, I'd have to plug that into the function to get the y value. So e to the natural log of 2 is just 2. So the point is natural log of 2, comma 2. Okay, so parallel to this line means it would have the same slope. Slope means derivative, so you set the derivative equal to that number. Okay, so really in this section we talked about two things. The first is your power rule. Your power rule is your quick way to find the derivative of any term. So the derivative of x to the 5 is 5x to the 4th. Power rule is just bring it down and subtract 1. And if there's a number in front, multiply by it. Okay, and the second thing is the derivative of what? Of e to the x is e to the x. So the derivative d dx, I should put in front, of e to the x is e to the x. Those are the two big ideas here. And then we just did a couple other problems that asked for horizontal tangent lines.